So, what is the perimeter? What does perimeter mean? What? What did you say? Yeah. So if I was like doing the perimeter of this green box but not actually walking all the way and pretending it cuts off there, I'd be like. And so what would I do? Just do what with the sides? Add them. This is probably why it's in this lesson, eh? And if I wanted the area for comic relief, I would do this. I had 2 people laugh, and now I'm going to be dirty. This is how clean our floor is. Thanks, guys, for mopping. Like, when has this floor been cleaned? And I knew it was this dirty because when I laid down on it, I could feel it on my face.
I didn't expect you to lie down on the floor.
It was for comic relief. You guys don't laugh, ever. If I can't even get you to laugh from laying on the floor, I got nothing. All right. So, we need to walk around. See, I'm here. Board's probably frozen. It's not. Why is it not working? Why?
Maybe you should just
Yeah, everyone laughs at you for that comment.
Yeah.
Why? I laid on the floor and now it doesn't know what to do with it. Draw. Yes. We have liftoff. Okay. So say I'm the blue dot. And then I walk around. How far did I walk? 3 root 6. It's literally right there. Thank you guys. So 3 root 6. And then I'm like, how far did I walk there? Plus 3 root 2. And then what do I need still? But we don't know the measurement. But it is a 90-degree triangle. And we did take grade 10 math. I don't care if you don't remember it. You did take it. And when you took grade 10 math, and you knew 2 sides, and you were missing the third side, how did you find it? It was a 90-degree triangle. I feel as though you got that from Luke and you took advantage, but I don't care.
Absolutely not.
Okay, so it's c squared equals a squared plus b squared, and you don't even need to memorize the formula. It's literally the 2 sides squared plus equals the hypotenuse squared, right? And the hypotenuse is the one that's across from the 90. So that's the one we're looking for. So when we are looking for the hypotenuse, we add the 2 sides. When we're looking for a missing side, not the hypotenuse, we take the hypotenuse squared minus the missing side, or the other side, right? So when we know the hypotenuse, we add them. When we need the hypotenuse, we add them. When we know the hypotenuse, we take it squared and subtract the other side, right? So you don't even need to memorize the formula, you just need to understand why you're doing what you're doing. So we're looking for the hypotenuse. We're looking for this third side, so we're going to add them. So c squared equals 3 root 2 squared plus 3 root 6 squared. Kind of leading into today's lesson a little bit. So that squared has to apply to the coefficient, the number in front, and the radical. When you square a square root, what happens? It cancels. You're right. So we're going to get c squared. Computer. C squared equals, now we square the number in front, which gets us a 9. And when we square a square root, what happens to it?
Cancel.
It goes away. It cancels. So we get a 2. And then the 2 numbers get multiplied, right? Plus 3 squared, which is 9. And when we square the square root, it cancels. We get a 6. So we get c squared equals 18 plus 54. So c squared equals 70. 70 rhymes with poo. 2. Thanks for asking me. And then how do we get c by itself? Square root it. Now what am I making you do here? Technically, when you take the square root of anything, just so you know, you get a plus or minus sign. When you take the square root of something, you get a plus or minus sign in front, correct? You should know that. Whenever you take the square root, put a plus or minus sign. But this is a measurement. Can we have a negative measurement? No, so it ends up being positive. So that's why you have always gotten positives when you did Pythagorean theorem. because you can't have a negative length, right? Now 72, what can I break down into? Its biggest perfect square. 9 is not its biggest perfect square. 36 times? Yeah. And the 36 comes out and it becomes a 6. So C equals 6 root 2. So when I walked along this side, I got 6 root 2. So I have to add that as well. And then what's my answer? 3 root 6 stays 3 root 6. Can't do anything. It doesn't match any radicants, other radicants, right? But the root 2's are the same, so I can get plus 3, 9 root 2. Very good. Then we're going to flip over. Okay, this one says, Kylie has a square dog run. So it's square. That means all sides are the same. What? Length. It has a perimeter of 32, so I'm going to write that off to the side. Perimeter equals 32. Now, how can we represent perimeter of a rectangle is 2 lengths plus 2 widths, right? Or length plus width, correct? But we don't use length and width when we talk about squares because they're all the same. So it'd be like length, 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 or width, 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 width. But is it a length or a width? So squares we often represent it as a side, as an S. So we have an S, we have an S, we have an S, we have an S. So the perimeter of a square is actually equal to 4 S's, right? Because S plus S plus S plus S is 4 S's. We walk around it. S plus S is 2S plus S is 3S plus S is 4S. Right? Okay. What else does it say? She wants to split the dog run diagonally. Now it says, what is the exact length of the diagonal section of the fencing? So what was the length of this? These are S's. How could I find out what they are equal to? Divide by 4. Because if the perimeter equals 32, I can put a 32 here, right? Equals 4S. And then I can divide by 4. So S equals 8 feet. So this actually equals 8. This actually equals 8. What's in this corner here? What kind of angle? A 90, a right angle. So this is the what that they're asking me to find? The hypotenuse. So the C. So you guys try and find it. So we are going to go C squared equals 8 squared plus 8 squared. C squared equals 64 plus 64. C squared equals 128. Then I take the square root, and when I take the square root, I put a plus or minus sign, because you always do that, and you need to practice that. But C is going to actually equal positive. So in the next step, the minus sign goes away anyways, because it's a length. Can I reduce 128 by anything? What? 16 times 8?
Oh,
It can be bigger than 64 and 2. So you could do 16 and 8, it's totally fine. You could even do 4 into it as well. You're just going to have to keep going. You have to do another step. Or 64 and 2. This is the quickest one, so I put an 8 out. So C equals 8 root 2 feet. And then because it's a word problem, and it says the exact length of the diagonal, exact length means do not turn that to a decimal. The moment you turn that to a decimal and round it, you've just taken off 0.5 of a mark. Because exact length means reduced radical, not decimal. So the diagonal section of fencing is 8√2 feet. We're going to look at this one tomorrow, not today, we practice for tomorrow. We're going to go to multiplication, the next lesson. So we did addition and subtraction, we do multiplication today, then division, then solving. So we go down to here. So it says, multiplying and dividing rational or radical expressions, we'll do rationals later. Solve problems that involve operations on radicals and radical expressions with numerical and variable radicands. So we have to have variables and numbers under your radical sign, is what it says. That's the curriculum that's given to us. So you have to be able to solve them with numbers, but you also have to be able to do it with variables. Okay? So tomorrow's quiz with adding and subtracting will have variables in it. We practice it with numbers today, just for that easing into it because of distance learning time. Or your brain just forgetting it. Multiplying radicals. So, how do we multiply radicals? We multiply the coefficients, so the numbers in front, and we multiply the radicands. So we multiply what's in front by what's in front, and what's underneath by what's underneath. That's it. Yeah. However, then we have to simplify every single time. So simplify, simplify, simplify is going to happen each time. Okay? If the index is even, state the restrictions on the radicand. When multiplying radicals with more than one term, use the distributive property. So that's going to make sense in a second. So here, we're going to do a warm-up. So what's in front of both of these? 1. So we're going to go √2 times √2 equals, we have an equal sign always, 1 times 1, which is 1. And then √2 times √2 is √4. √4 is actually 2. So this is 1 times 2, which is 2. So something to learn. When you multiply two radicals together that are the exact same, you just get the number without the radical sign. So if I did √3 times √3, it would be √9, which is 3. √5 times √5 is √25, which is 5. So whenever you multiply two radicals together with the same radicand, you get the number without the square root symbol. Now where the error lies is when you go √2 times √2, you go √4, and then people will somehow write √2 here. You keep the square root sign for some unknown reason. It's like an addiction. You must keep it. So don't do that. √4 is 2. So if you skip from √2 times √2 equals 2, because you know that rule, that's fine. When you multiply two radicals that are the same together, you get just the number, because √2 times √2 is √4, which is 2. Works every time. So what's √3 times √3? 3. And how do we prove that? Because √3 times √3 is √9, which is 3, right? √x times √x equals x. Because √x times √x is √x squared, which is x. Remember 2 for 1? So 2 x's can come out and become 1, right? So this can go like this. And then this whole thing run away. So sometimes it's actually easier to know that when you have 2 of the same, you can cancel it. With cube roots, you have to have 3 of the same. So the cube root of 5 times the cube root of 5 times the cube root of 5 is actually 5. And I'll show you how that works. So the cube root of 5 times 5 times 5 is 125, which is 5. Remember, it's like a 3 for 1 special, correct? So instead of writing it this way, I could have wrote it as the cube root of 5 times 5 times 5. And all 3 of these can come out and become a 5, right? When it's cubed, 3 for 1. Next page. Okay, task 1. Multiply. Express each answer as a mixed radical in simplest form. You will always, it doesn't matter what we're doing, it'll say simplify. And how do you know to add and subtract? It has addition and subtraction signs. How do you know to multiply? It has multiplication signs or brackets. If a bracket is touching a bracket, that means multiply. Okay? But the heading for all of them will be simplify. And how you'll know what operation is? By the operation it shows, right? So here it says you need to multiply coefficient by coefficient and radicand by radicand. You also simplify first so your numbers aren't too large. So if you don't simplify first, that's fine. You're going to be reducing a really large radical at the end. So sometimes simplifying along the way before you multiply actually makes it a little easier to simplify in the end. Okay? So this root 5 and this root 3, can I reduce those at all? They're as low as they can go. So the first thing I can only do is multiply. So I'm going to get 6 times 2, which is 12. And I know I'm multiplying because it's a bracket touching a bracket. That's another way of showing multiplication. And then square root 5 times 3, which is 15. Then before I box it, I always say, hey, at 15, can I reduce it? Anything on the chart? 4, 9, nope, done. Now for the try, we're going to do it together, and then I'm going to get you to do B in the other try. But for the try, if we go right ahead, we could go square root 1/3 times, and then go times 1, which is 1/3. And then square root 45 times square root 10 is 450. And then we're reducing 450, which is a really large number, but we could do it that way. Okay? Or we can reduce first because root 10 can't reduce, but root 45 can. What does root 45 break down into? 9 and 5. And when the 9 comes out, it becomes a what? A 3. So the reducing from grade 10 is extremely important. And what's 3 times a third? 1. It actually became nicer when you did that. So you get 1 root 5. If you want to show the 1, you don't have to. And then 1 root 10. So the numbers are smaller now, right? That doesn't mean just because you simplified in the middle doesn't mean you're not going to have to simplify at the end, too. You might still have to simplify again. But at least you're not simplifying 450. So now we're going to get 1 times 1, which is 1, and then root 5 times root 10, which is root 50. Can I reduce root 50? Yeah, to what? 25 and 2. So I can do that one quickly. Root 450 might take me a little bit longer, right? So even though I have to do an extra step simplifying twice in here, it often will get people not stuck with really large numbers reduction. So bring the 25 out, it becomes a 5. So my answer is 5 root 2. You guys are going to try the B and the try. What happens when you multiply variables with same base? What do you have to do with the exponents? Add them. So if I have like x to the 2 times x to the 3, it's actually x to the 5. You only multiply when it's like this, when they're touching. 1 base, multiply, 2 bases, add. Okay, so try out B and C, or B and try and see how you do. Let's through and see what we can do. So, root 28, can I reduce that at all? What? 4 and 7? Yeah. When I bring the 4 out, it becomes a 2, and what do I do with these two numbers? Multiply. So I'm going to get 6 root 7. 14, can I break down? No. So I'm going to get 1/4 root 14. Now, I do outside times outside, radicand times coefficient times coefficient, radicand times radicand. So 6 times 1/4 is what? Is 1.5, but I'd rather it as a fraction. You have a math ed random button that can do it for you. If not, you can go 6 divided by 4, which is what it would be. And then take a 2 out of both, which is 3/2. But your calculator will double check that for you. And then 7 times 14 is what? 98. And 98 breaks down into what times what? Sorry? 49 times 2. The 49 comes out and it's a 7. Then when you multiply fractions, it's numerator times numerator, denominator times denominator. Some people are like, do I cross? You don't cross multiply. You cross multiply across an equal sign. If there's an equal sign in between, you cross multiply. If it's just multiplication, it's top times top, bottom times bottom. And any number has a denominator. If it doesn't have one, it's 1. Right? So I put a denominator on it. So it's going to be 21 over 2, root 2. Okay. This one I have 27x5 and root 3x7. I can reduce the x's in both, for sure, and the 27. So 27 breaks down into what times what? 9 times 3. And the x's, if it's confusing, remember you can just go like this. And it's a 2 for 1 special. So the 9 is going to come out and be a 3. And then I'm going to get 1x, 2 x's. And when I bring them out, they're multiplied. So what are they going to be out here? X squared. And then those cancel. And then I have root 3x7. Now you can break these up into x squareds as well. So this would be 3 times an x squared times an x squared times, I'm running out of room, put it right up here. So I could do it 2 ways. So I can go 3, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3 x's, so I get an x cubed up front. I can do it that way, right? That was one way I showed you. Another way you could do it is you could break it into as many x squareds as you can. So you could go 3 times x squared times x squared times x squared is 6 x's, right? Because it's 2 plus 2 plus 2 times an x. And then each one of these comes out as a 1. 1x, so it would be x cubed, right? Or, if you're more advanced, you could even go 3 times x to the 6 times x, and an x to the 6 comes out as an x to the 3. Always comes out as half of it. Which one do you choose? Whatever one works for you and gets you the right answer. I don't care which option you pick. I just care you pick one that gets you the right answer. All 3 of those work. So I don't care which one works for you. You pick the one that works for you. Does that make sense? So if it's this one, go for it. If it's this one, yep. If it's this one, yep. If you swap between the few, whatever, I don't care. As long as you get the right answer. So it's going to give you x cubed on the outside. X cubed root 3x on the inside. So this one here is 3x squared root 3x. And this one here is x cubed root 3x. So when I multiply outside times outside, I get 3x squared times x cubed. What do I get? 3x to the 5. So I have the same base I add exponents. That's grade 10 outcome. 3x5. And then the radicand, I'm not going to write that. I go root 3x times root 3x. What does that get you? Making it harder on yourself. What happens when we multiply 2 radicands that are the same together? You just get the answer. The radicals drop off. It's actually more work to write root 9x squared and break that down to 3x because there's a chance you might make an oopsie. You need to spot that if you get root 3x times root 3x, your answer is 3x. If you got root smiley face times root smiley face, your answer would be smiley face, right? You get root porky pig times root porky pig, your answer would be porky pig, okay? So in this case, because I have root 3x times root 3x, I just get a multiplication of 3x behind it. You could show the step root 9x squared and then do 3x. It would get you the same thing. But I know that people error there all the time. So we're actually going to get 3 times 3, which is 9. X to the 5 times x to the 1 is actually x to the 6. 2 bases, we add exponents. We're not going to do the harder multiplication till tomorrow. So we're just doing this because I want you to get used to this. Radicand times radicand, coefficient times coefficient. Simplify, simplify, simplify. If I put foiling into this or distribution into this, then simplify, it's almost too much in one day. Okay, so we're sticking to this. So you guys have to do your homework tonight. I know you can push it till Friday, but it won't be pretty tomorrow if you do. That's on you. So I'm going to leave it to you to make that decision. So, you're doing page 289, number 1. And if I were you, I would do page 289, number 1 right now, so when you make errors, you can ask me, right? Page 289, number 1. Tomorrow's will be more homework, so enjoy tonight's. Page 289, number 1. And I would do it right now while you're here with me, so you can ask questions. Because I need to have this down really well so that tomorrow's lesson isn't a disaster.